class 9. Today we'll be continuing with our discussion with covalent bond. So in our previous video we have to discuss about different structures about covalent bond, and this is the continuation of chapter 4. So today we will be discussing about the molecule of HCl. So this HCl, okay, is a compound where covalent bond is involved. So let's discuss this. So hydrogen has only one electron and it has one cell. So that electron is present here, say. And chlorine, you know chlorine. Chlorine has three cells. First, second, and third. So in the first cell it has 2 electrons. In the second it has 8 electrons. Okay? And in the valence cell it has 1, 2, 3, 4, 5, 6 and 7 electrons. So whenever this hydrogen and chlorine they come together to form a compound, then they go for sharing of electrons, that is mutual sharing of electrons. So this is the structure of hydrogen and chlorine before the combination. Now after the combination what happens is chlorine, as you know, it has 3 cells, 2 electrons, eight electrons in the second cell, okay, and in the third cell so let me draw it properly first. And in the third cell it has how many electrons? 7 electrons. So 1, 2, 3, 4, 5, 6, 7. 7. The seventh one I haven't drawn. Now hydrogen has a single orbit and it has only 1 electron. Now whenever these two they come together, then what they go? They undergo sharing of electrons. Now once these electrons are shared, that means this electron is with this hydrogen as well. That means 1 plus 1 is 2 for hydrogen, that is its duplet configuration is complete. And for this chlorine, it has how many? 7 electrons in the valence cell, and whenever it shares 1 electron of hydrogen, then its octet is also complete. Therefore, they undergo mutual sharing of electrons. Now suppose, let me draw the structure once again. Here suppose hydrogen and chlorine they have come together. Now what happens is this electron of hydrogen is shared with chlorine and an electron of chlorine is being shared with hydrogen. This is how we draw this structure of chlorine. Now if you go for electron bond structure and yesterday I told you that in electron bond structure what do we have to consider? We have to consider only the valence electron. That means hydrogen has 1 electron. This is the electron of hydrogen. Whenever it reacts with chlorine, and only the valence electrons of chlorines are written for this electron bond structure. Now what will happen? Now they undergo sharing of electron. Now once they share the electron, then we can represent it as this. These are the 7 electrons of chlorine and this electron of hydrogen is shared with this chlorine. Okay? Now as a result what will happen? Now octet of chlorine is complete and the duplet of hydrogen is complete. Now this can also be represented as HCl. These two results in the formation of bond. Okay? These two results in the formation of bond. This is how you draw the electron bond structure of HCl. Now you have to be very careful that these electrons, these 2 electrons are shared, therefore this sharing has to be shown. Okay? So this is the structure of HCl. Now let's discuss about the structure of ammonia. Ammonia, you know, where do you find it? As I told you in class, I've already told you in class, where do you mostly find it? Now, you must be knowing the formula for ammonia. The formula for ammonia is NH2, nitrogen, atomic number is 7, so its electronic configuration is 2, 5, and hydrogen, you know, it has only 1 electron. So in the valence cell, how many electrons are present? 5 electrons. So you need to consider this, okay? Now, nitrogen contains how many electrons in the valence cell? It contains 5 electrons in the valence cell. 1, 2, 3, 4, 5. So it has 5 electrons in the valence cell. Now, how many more electrons do it need for octet configuration to be stable? So it has 5 electrons. It needs 3 electrons. Now, those 3 electrons are shared with hydrogen. Now, three hydrogens will share its electrons with nitrogen. That means they are going to go sharing of electrons. Now you can draw with the help of orbit for hydrogen, and these are the what? These are the electrons of hydrogens. Now again they undergo mutual sharing of electrons. Now as a result, what you obtain is you obtain nitrogen. So I am drawing here nitrogen with its orbit. 2 electrons are staying as lone pair. These 2 electrons haven't taken part in bond formation. Therefore, it is known as what? Lone pair. Now, 3 hydrogens, 1, 2, and 3. The hydrogens are present here. Hydrogen and hydrogen, and those electrons, these electrons are shared between hydrogen and nitrogen. Therefore, it is written within the orbit of hydrogen as well as within the orbit of nitrogen. Therefore, these shared electrons has to be written within the orbits of nitrogen as well as hydrogen. So now, if you go for electron product structure, nitrogen has how many electrons? 5 electrons in the valence cell. So, whenever it combines with hydrogen has 1 electron. It combines with 3 hydrogens. Okay? Now what will happen? They will go for mutual sharing of electrons. As a result, we will be having NH, H, and H, and these 2 electrons you can show it as lone pair here. Now this is equal to what? This is equal to 1 nitrogen and 3 hydrogen, NH3. So this is the electron orbital structure of NH3. Now let's discuss the structure of methane. So these structures are very easy. Okay, once you know the electron number of electrons in the valence cell, their atomic number, then you have to keep in your mind that they will go for sharing of electron to either to be octet. Octet means they need to have 8 electrons in the valence cell, or to have 2 electrons in the valence cell, which is duplet configuration. So we are going to discuss about methane now. Carbon, atomic number is 6, electronic configuration 2, 4. Therefore, how many electrons are present in the valence cell? 4. So it needs 4 more electrons to be octet, 8 electrons. Therefore, it is forming bond. How many bonds? 4 bonds with hydrogen. Why? Because each hydrogen has 1 electron and it is going to share with carbon. Okay? So let me draw the structure of CH4. So we have carbon, and carbon in its valence cell has how many electrons? 1, 2, 3, 4 electrons, as it is evident from this one. Hydrogen has, how many hydrogens are reacting with carbon? 4 hydrogens. Plus, plus, plus and plus. And each hydrogen has 1 electron in its valence set. Yes or no? Now, they will undergo mutual sharing of electrons. And once these electrons are shared, duplet of hydrogen is complete. Of each hydrogen is complete, you can see that. And for carbon, its octet is complete. You can count it 1, 2, 3, 4, 5, 6, 7, 8. Okay? Therefore, we have carbon, and here we have hydrogen. Hydrogen. How many hydrogens? 4 hydrogens. So these are all hydrogens. And in all the cases, you can see all the hydrogen, all the electrons of valence electron of carbons are shared with hydrogen. Therefore, these electrons are written within the orbits of hydrogen as well as carbon. That means these are common to carbon as well as hydrogen. Now this is the structure of this CS4. Now let me draw the electron dot structure. Now for electron dot structure, you need to consider, as I told you, you need to consider only the valence electron. Now carbon has how many electrons? 4 electrons. Carbon. So carbon has how many electrons in the valence set? 4. 1, 2, 3, 4. Hydrogen has 1 electron in the valence set. Now these are coming together to form covalent bond, that is mutual sharing of electron takes place. These electrons are shared between hydrogen and carbon. Now once these electrons are shared, how can you represent them? You can represent them as here. I am writing it here. Carbon. These electrons are present between hydrogen and carbon. And here the electrons are present between hydrogen and carbon. Here also the electrons are present between hydrogen and carbon. And here too the electrons are present between carbon and hydrogen. Therefore, this can be represented as what? C1 carbon. And how many hydrogens? This can be represented as, so first we will show a bond formation between them. So carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, and carbon, hydrogen. So this is the structure of electron dot structure of methane. So you have to follow 3 steps. So in the first, you show electrons present, only the valence electron. Please remember that. So valence electrons present in the combining atoms. You have done that. And after that, this step, both electrons are lying exactly in the center between the combining atoms. And after that, the end one, we have to show the bond formation. One more step you can write, that is, this is equivalent to what? C1 carbon, and how many hydrogens are there? 4 hydrogens, CS4. So let's discuss one more structure which is there in your syllabus of class 9, that is CCl4. Now instead of this hydrogen, what we have? We have chlorine, CCl4. CCl4. Again, carbon 6, 2, 4, 4 electrons in the valence. Chlorine, you know, it is 70, 2, 8, and 7. So, we are going to consider these electrons. Okay? Carbon in itself has how many electrons? Valence 1. Let me represent the electrons of carbon with cross sign. Okay, small cross sign. 1 electron, 2 electron, 3 and 4. Here we have chlorine, and in the chlorine we are considering the valence cell. How many chlorines are there? 4 chlorines. Therefore, we need to take 4 chlorine. This is chlorine. And here we have what? 4 cells. Now this 4 chlorine are combining with carbon. And in the valence cell, you know how many electrons are present? 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. Okay? Now one thing I would like to suggest to you all is, see, whenever you have these electrons, okay, of any element, atom of any element, if they are going to combine, if you want to show their mutual sharing, then exactly to the opposite of that you need to have a single electron, so that it can be shown as here. Okay? This now will undergo what? Mutual sharing of electron. As a result, what we get? We get this structure, carbon, and how many chlorines? 4 chlorines. 2, 3, and 4. So here, see, let's consider this chlorine. Okay, this chlorine is sharing its 1 electron with this carbon. The other 6 electrons are not same. That means it is remaining as lone pair. Therefore, those lone pair it has to be written here outside this the reach of this carbon circle. Okay, so please remember this: 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, all the valence electrons of carbon, all the valence electron and 1 electron of each chlorine is being shared with carbon. Yes or no? Therefore, these electrons has to be written in between now. 1 electron of carbon and 1 electron of chlorine. 1 electron of carbon, 1 electron of chlorine. 1 electron of carbon, 1 electron of chlorine. And 1 electron of carbon and 1 electron of chlorine. Now you can see from this diagram that within the orbit or circle of this carbon, how many electrons are present? 1, 2, 3, 4, 5, 6, 7, 8. Therefore, its octet is complete and is very stable. Now let's discuss for chlorine now. Look for each chlorine over here. Each chlorine, it has 1, 2, 3, 4, 5, 6, 7, 8. So you can count for all the chlorine will have the same 8 electrons and becomes very stable. This is how these different atoms of the elements they undergo mutual sharing of electrons to gain either octet configuration or duplet configuration, so that they will be very, very stable. Okay? Now let me draw the electron structure of this particular compound now. So once again, let me remind you. See, I have been reminding you again and again, and this is so important, and I want you to remember it. Okay? Please remember this, that for electron dot structure, you always consider only the valence electron. So, carbon, how many electrons does it have? How many electrons? Carbon has 4 electrons in the valence cell. 4 electrons. So, 1, 2, 3, 4. And chlorine has how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4 chlorines are there. Therefore, I am writing this electron dot structure of CCl4. Now these are what? Going to combine. This is positive sign. And this cross represents the electrons, the valence electron of carbon. Now they undergo what? Mutual sharing of electron. Now once they undergo mutual sharing of electron, so you can write this in this form. So carbon 1, 2, 3, 4, and chlorine here 1, 2, 3, and 4. So it has 1 electron of chlorine, 2, 3, 4, 5, 6, 7. So similarly, 1 electron of chlorine here. 2, 3, 4, 5, 6, 7. 1 electron from this chlorine. 1, 2, 3, 4, 5, 6, and 7. So 1 electron from chlorine, from this chlorine. So 1, 2, 3, 4, 5, 6, 7. So this electrons, you can see why this is written together. 4 electrons from carbon and 4 electrons of this 4 chlorine. Okay? 1 electron from each chlorine. They have come together and they have stayed together. Now this will result in the formation of covalent bond. Now in the next step, you can show it with this structure where you have this is not chlorine, this is carbon C. Okay? This is not Cl. This is only carbon C, and these are all Cl. Now this can be shown. Now this the bond between carbon and chlorine will be shown in the next step. That is carbon forming a bond with chlorine. This is chlorine, 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 and this is also Cl. This is Cl. Cl, Cl, Cl. Now these bonds these bonds are as a result of this combined electrons. Now this can be written as CCl4. So this is how you draw the electron bond structure and the atomic orbit structure of different covalent compounds. Now with this discussion, we come to the end of this chapter number 4. Now I want you to practice all these things. This once you practice, it becomes very, very easy. Okay? Please practice, and your assignment is to solve the exercises after this particular topic. So in the next video, we will be starting with a new chapter. Till then, take care. Thank you.